Alright, here's a video to help those who might be gone for 4.4. This is solving equations that have radical expressions or inequalities. So here's the idea. We're going to have expressions that have, like in example 1, square roots and cube roots. Or we might have examples that we have, let's see, down on example 5 and 6 where we have rational exponents. So first thing that you're going to want to do is to pretty much you want to get the radical expression onto one side. So get radical expression by itself if possible. And then you're going to square or cube the equation depending on what's necessary. You're going to solve, and then you're going to check solutions. Okay, so if you need to pause that to write this down, go ahead and do so. I'm going to go on and do some of these examples down here. So for A, we have 2 square root of x plus 1 equal to 4. Now we want to get this radical expression right here by itself, meaning I'm going to divide by 2 on both sides. So when I do that, I'll have x plus 1 is equal to 2. Now that the radical expression is by itself, I'm going to square both sides. Square the equation. On the left side, that will leave me with x plus 1. On the right side, that will give me 4. And now it's just an equation that I can solve, so subtract 1, and x will be equal to 3 right there. And there you go. Now this one we might not have to check our solutions, but it might be a good thing to try out. But in any case, I'm going to go to B, where I have the cube root of 2x minus 9 minus 1 equal to 2. So we want to get this radical expression by itself, so we add 1 to the other side. So we have the cube root of 2x minus 9 is equal to 3. Now that the radical expression is by itself, I'm going to cube both sides. That will give me 2x minus 9 equal to 3 cubed, which is 27. And now I solve for the x variable. So I can add 9, and that would give me 2x is equal to 36. When I add 9, divide by 2, and x will be equal to 18. There you go. So those are some of the more simpler equations. So if you want to review that, go ahead and pause the video. I'm going to go on to this next part. In example 3, we're going to be solving an equation with an extraneous solution. So an extraneous solution just means extra solution that doesn't work with the original equation. Let's just say that it's an extra solution that does not actually work with this equation. So I'll show you how we can get that. So notice that right here we do have the radical expression by itself. So that gives us the option to just go ahead and square this side and square this side. But you can see that on the left side, this gives me a binomial of x plus 1. Okay, so here on the left side I'd have x plus 1 squared, which is equivalent to x plus 1 multiplied by itself. So you have to expand this binomial. So we can do that by the FOIL method. So I can multiply those together. In any case, I get x squared plus x plus 1 or x squared plus 2x plus 1. So when I square both sides, I get x squared plus 2x plus 1 on the left, and on the right, I'll get 7x plus 15 without the radical. Now notice that by doing this, I actually have a quadratic equation right now. And to solve quadratics, we want them equal to 0. So I'm going to subtract 7x and subtract 15. So I have x squared. I'd be left with negative 5x, and then that would be minus 14 equal to 0. Now that I have the quadratic equal to 0, factor the quadratic if possible. So that would give me, I need two numbers that multiply to be negative 14 and add to be negative 5. That would be minus 7 and plus 2. So here x is equal to 7 and x is equal to negative 2. So I have two solutions. But I should only have one. The reason I have two solutions is because I raised this equation to the second power and got a quadratic from it. And quadratics have two solutions. But this equation should only have one. So I need to check and see, maybe potentially, which one of these might not work. So let's try negative 2. So if I plug negative 2 into this spot and this spot, will the equation be true? So I'd have negative 2 plus 1 equal to the square root of 7 times negative 2 plus 15. And now let's simplify. So on the left side, I'd have negative 1 is equal to the square root of, that would give me negative 14 plus 15 right there. So that's negative 1 is equal to the square root of positive 1. Square root of 1 is 1, so negative 1 equal to 1, which is a false statement right there. And so that means negative 2, the one that we plugged in, is not a solution. Okay? So negative 2 is not a solution. Only my x equals 7. Now you can go ahead and double check. You can plug in 7 and you can make sure that that is a solution, just if you want to verify that. But I believe we should be okay right there. So yeah, whenever you get two solutions, you should always be checking to make sure that that all the solutions remain true. So if you want, you can do that at a calculator, you can do that by hand, you can do that by graphing, which way you think would be easiest for you. So those are problems with extraneous solutions. Alright, example 4. Here is a radical or an equation with two radicals inside it. So here's this side and this side. So like we said before, if possible, we want to get the radical expression by itself. But since we have two radical expressions, that's not going to be an easy thing. So we kind of have to just deal with it and see what happens. So I could subtract the 1 over here, but it would be the same thing. I would have pretty much almost the exact same kind of expression on both sides. So since we don't have that, let's go ahead and just square both sides anyways. So we're going to square both sides. Now on the left side, that would give me the square root of x plus 2 plus 1 squared. Now this right here, I can't just square both of them because this is a binomial. So I have to write this out as square root of x plus 2 plus 1 multiplied by the square root of x plus 2 plus 1. So here's a binomial that I have to FOIL to expand. So let's try that out. So here I have the square root of x plus 2 multiplied by the square root of x plus 2. That is x plus 2 squared, square root of x plus 2 squared. So I would just be left with x plus 2. Square root of x plus 2 times by 1 is the square root of x plus 2. And then the inner terms would be 1 times the square root of x plus 2, which is square root of x plus 2. So I have square root of x plus 2 plus the square root of x plus 2, and then I have 1 times by 1, which is 1. On the right side, I would have 3 minus x. The radical would go away. Notice here that these inner terms that I have are like radicals. They have the same nth root, and they have the same radicand. So I can add the exponents. So I have x plus 2 square root of x plus 2 plus 1 equal to 3 minus x. So now you see that my equation only has one radical expression instead of two. So same thing, I want to get this radical expression all by itself. So I would subtract the 1, subtract the 1, subtract the 2 here, subtract the 2 here, subtract the x there. So then I would be left with only this on the left side. So 2 square root of x plus 2 equal to, right here, that would end up being 0, and this would end up being negative 2x. Divide by 2, so that I'd have x plus 2 on the left equal to negative x on the right. And now I can get rid of the radical by squaring both sides. Let me move my work over here. I would have x plus 2 is equal to negative x squared is just going to be x squared. And I have a quadratic expression. So let's set the quadratic equal to 0 by subtracting x and subtracting 2. So x squared minus x minus 2 equals 0. Factor the quadratic if possible. So I need numbers that multiply to be negative 2 but add to be negative 1. That would be negative, let's see, multiply to be negative 2, add to be negative 1, that would be negative 2, positive 1. So x would be equal to 2, and x would be equal to negative 1. Now I have two solutions here, so I'd have to check. You could check 2, you could check negative 1. I'm just going to go ahead and cut to the chase. 2 is not a solution, 2 is not a solution. So 2 doesn't work, but x minus 1 is. So you can check that by plugging it into the original equation, but for the sake of time, I'll just let you know right now. Okay, so here are some examples if you want to go through those. I'm going to jump to example 5, where we talk about rational exponents. And rational exponents really aren't that different. So we want to get the rational exponent by itself. So I'll subtract 2 from both sides. So I get 2x to the 3/4 is equal to positive 8. Now, I'm going through these really fast, so please pause the video if you need to stop and review my work, but I'm just trying to get these done pretty quickly for the sake of time. Then I'm going to divide by 2, so I get x to the 3/4 is equal to 4. Okay, so now to get rid of this right here, let me write this a little bit more clearly. I have x to the 3/4 power. Now, I need to get rid of this rational exponent, and it's actually not that bad. So if we think back to our rules about exponents, I know that x to the 1/2 power times by, or raised to the 2nd power, is equal to x. Because here, I multiply the exponents, but 1/2 times by 2, its reciprocal is equal to 1. Which is why the product, or that, simplifies to be x to the 1st power. So it's the same kind of concept. If I raise this expression right here to the 4/3 power, meaning I have to raise this side to the 4/3 power, note that 3/4 times by 4/3, a fraction multiplied by its reciprocal is always going to be equal to 1. Always. So then on the left side, I'd be left with x, because 3/4 times by 4/3 is 1, so it'd be x to the 1st power. And then here I'd have to the 4/3 power. So just to simplify that right side expression, that would be 4 to the 1/3 to the fourth power to the 1 second, I messed up here, hold on. I can't divide by 2 here, so I subtracted 2 and I got 8, but this is in parentheses, so I was not able to divide by 2. But in any case, we still do the same thing. So we raise this to the 4/3 power, raise this to the 4/3 power, which would give me 2x equal to 8 to the 4/3 power. And then right here, I want to solve this, or simplify this expression right here. So I have 2x equal to 8 to the 1/3 power to the 4th power. So I have 2x is equal to 8 to the 1/3 power is 2. 2 to the 4th power is equal to 16. And now I can divide by 2. And so I get x is equal to 8. Okay. So it's just all about raising this to a power that is its reciprocal. So if you need to pause that to review that, go for it. I'm going to go to example 6. So I have x plus 30 to the 1/2 power. This radical expression is already by itself. So I could square this, which is the reciprocal of 1/2, but I square this side as well. So I would end up with x plus 30 is equal to x squared. Note that I have a quadratic expression equation now. So get the quadratic set equal to 0, so I could subtract x, subtract 30. So x squared minus x minus 30 is equal to 0. Factor the quadratic expression to x, let's see, minus 6 and x plus 5. So then find the zeros. And then you would have to check your solutions. So in this case, 6 is a solution, but 5 is not. Negative 5 is not. So if you check that, you'd get that. You'd come to that conclusion. Alright, last problem here is radical inequalities. So here, it's an equation, but with an inequality. So go ahead and solve it like you probably normally would, just maintaining the inequality. So here I'd subtract 3. And I'd be left with the square root of x minus 1 is less than or equal to 4. Square both sides, so I get x minus 1 is less than or equal to 16. And we can add 1, and we get x is less than or equal to positive 15. Now we have to be careful about radical inequalities when the radical has a second, or when it's an nth root. A square root, because square roots, this radicand underneath a square root cannot be negative. Remember that radicands in square roots cannot be negative. So, meaning that x minus 1 has to be greater than or equal to 0 right here. This is another radical inequality expression that you have to solve for. So you always have to do this for square roots or fourth roots or whatever. So you take the radicand and set it greater than or equal to 0, so it's an additional inequality that you have to solve for. But this one's pretty easy. X has to be greater than or equal to 1. So here are the two parts of my solutions, where x is less than or equal to 15, but greater than or equal to 1. So this would be the solution to this inequality. Okay, so that should pretty much be it. Note that you don't have to do that for cube roots right here, so you don't have to do that for cube roots, only square roots. So here you have to make sure that after you solve the inequality, you have to make sure that this right here fits with your inequality, and same with right here. Okay. Alright, so that should pretty much do it for 4.4. Hopefully this is a helpful video, and make sure you let me know if you have any questions.